To find the horizontal asymptote, that will be described in a later portion. However, for now, let's just think about it this way. Now, most of the time, we're going to be dealing with practical situations. Rarely do we just model so that we can model. But in a practical setting, to find the horizontal asymptote, we want to ask ourselves one of the following questions. Well, as you move towards a vertical asymptote, keyword, as you move towards a vertical asymptote, what happens to the output values? Do they go to negative infinity? Do they go to negative infinity? And or, if both these make sense, you go with both of them. As you move away from a vertical asymptote, what happens to the output values? Do they go to infinity or negative infinity? Well, the way we're going to worry about doing that right now is to say, okay, well, in this scenario, our vertical asymptote occurred at the value h equals 0. So, in this context, it didn't really make sense to say as we go towards the vertical asymptote, because to go towards it, we would basically have to move from left to right. So towards we mean from left to right. And that doesn't really make sense because these are all negative input values, so we just really don't deal with those. But if we move away from the the vertical asymptote, then we can figure out what's happening to the outputs. Well, how do we do that? Well, we built a table. According to the table, as we increase the number of weekly hours, what happened? Well, the hourly wage, as we increase the number of hours towards infinity, the hourly wage went down to 0. Well, I guess we could say the same thing coming from this direction. When we saw the graph, it kind of looked like there was a mirror image down here. And it's the same thing, it approached this asymptote. So we could also say, if it made sense, as h approaches 0, in other words, as we get closer to this asymptote, what happens to w? Well, if you can work negative hours and you got closer to 0 hours, the wages would approach negative infinity because these guys just drop down forever. But coming from the vertical asymptote moving to the right, the wages go down towards 0. So whichever one of these makes sense. Now, we have to figure this out by sort of looking at a table. So a simple way is to basically, once we have our model built, is to kind of study and see, all right, well, what happens? Well, in our graph, in this scenario, remember, this had the vertical asymptote at x equals 2. And if we looked at the graph of it, we saw, okay, well, first of all, depending on what we're modeling here, it may not make sense to have negative values. Maybe from 0 to 2 it makes sense to have output values. But let's just say we went from 2 on. So from our vertical asymptote, we went onwards this way. Well, you might say as x approaches infinity, this curve goes down to 0. Well, let's see if our claim would make sense. So, well, oh, there it is. At 2, the outputs are undefined because we get 0 in the denominator. But as we start to move, basically increase the input value, now look at that. Suddenly the process is starting to slow down and those outputs are getting smaller, but it's taking them a really, really long time. So, well, I don't want to keep scrolling through this. It's taking forever. So what I'm going to do is I'm going to come over to my table set, and I hit second window, and I'm still going to start my table at 0, but I'm going to have my table increments go up by maybe 100. Just because I really want to see what's happening to the end behavior of this function. What are the outputs going towards? Well, after we get to 100, we're at about 1.56. And as we continue to increase by 100, the inputs by 100, the outputs, look at that. They're really just getting closer to 1.5. So I speculate, or my hypothesis would be, wow, and they're moving very, very slowly, that as x approaches infinity, it appears that y is getting closer to 1.5. Now, here's a little foreshadowing. Look at the coefficients of the x. 3 divided by 2. That's 1.5. And we'll talk more about that later.